In this video, we are going to talk about polyatomic ions. What are they? Learn the names, the chemical formula, and the charge, and know why they are important. So, at this point in the semester, you should definitely know when I have nonmetals bonded to other nonmetals, I should know the number of bonds that they're going to form, depending on their location on the periodic table. And I should know the number of lone pairs that are also present. So, for example, oxygen has, with H2O, with water, I have two covalent bonds, just like I'd expect, two covalent bonds, and two lone pairs. But what happens when an atom doesn't have the number of bonds and lone pairs expected? So we look at water, and water has its two covalent bonds and its two sets of lone pairs. It has an octet of electrons. What if instead of having two covalent bonds, it has an extra set of lone pairs, so three lone pairs? Well, the result is instead of sharing those electrons in that bond, it's all on the oxygen, and we have a charge, it's called a formal charge, of -1. I'm not going to ask you to calculate them. I just want you to be aware that that's how the charge comes about. And we can write that OH -1 like this. We can write that OH like this, -1. We can include all the lone pairs. We have all of the different options for the way to show how we have this minus charge on the OH. And we can put it in the front or put it in the back. I usually put it on the oxygen because that is actually where the minus charge is located. But a lot of times you'll see it like this, and they are both correct. Okay, so let's talk about this term polyatomic ions. Ions. What's an ion? If you're saying ion, I absolutely know an ion has a plus or a minus charge. Yay. Poly means many. Many atoms, polyatomic, many atoms make up this molecule that overall has an ion. Okay, so carbonate is our first example. And you need to know the name carbonate. You need to memorize them. I recommend making flashcards. You have carbonate. It is CO3. This is the formula for it, CO3. And it has a -2 charge. And this is the Lewis structure of it. So right when you're looking at the Lewis structure of this, you've never seen anything like this before. Here you have these covalent bonds. I have these covalent bonds, right? The sharing of electrons between them. But I also have an ion. I have an ion because the oxygen has three lone pairs instead of the expected two. So that's why this is called a polyatomic ion. You do not need to know, do not need to memorize these, do not need to memorize these, need to memorize these. But I find that actually just visualizing where the heck this is coming from, these polyatomic ions feel less foreign. They're covalently bonded to each other, and they have ions because they differ in the number of lone pairs from the number of covalent bonds you'd expect. Okay, so I have the next one that you need to memorize is hydroxide. I have hydroxide, hydrogen, and then the oxide, it has a minus charge. This is the formula for it, and the charge is a -1. You don't need to know the Lewis structure. I have nitrates, NO3. I have 3 oxygens, 1 nitrogen with a -1 charge. Sulfates, sulfate, I have sulfate as SO4 and a -2 charge. Again, I have these covalent bonds and I have a formal charge on those. Oops, I'm missing one. Formal charge on those oxygens, giving me a -2 total. And that's where that -2 comes from. So I need to know the name. I need to know the chemical formula. I don't need to know this. We're just talking about it so you can see where it comes from. Phosphates. Phosphate, PO4 -3, if it's a -3 charge. And the last one, notice it's in a different color. So it's in a different color than the rest of them. And what do you notice about ammonium? How is ammonium different than the rest? Well, it has a plus charge. So ammonium is nitrogen with 4 hydrogens attached, and the plus charge is on that nitrogen. So you might see it written like this, NH4 bracketed with a plus charge. You could see it drawn like this with a plus charge on the nitrogen, or you could have the plus charge right next to the nitrogen. You're not responsible for this. You are responsible for these. Okay, so those are polyatomic ions in a nutshell. You need to know the name, and you need to know the formula, and you need to know what they are. Why are they important? So I've given you a bunch of examples of why they're important. They're found, carbonates are found in bones, phosphates are found in bones, sulfate are involved in cell growth and development. Nitrates are also found in your body, and hydroxides are a corrosive base. So those are just actually important in reactions. So that is the end of this video for polyatomic ions, and I will see you in the next video.